রাইট। তো দেখ লাস্ট যেদিন the last point যেটা আমরা ডিসকাস করলাম, that was regarding electric dipole. And what I told ki electric dipole ta ki hoy, electric dipole is basically a system of two charges, point charges minus q and plus q, which is separated by some small distance, ঠিক আছে? এই ডিস্টেন্সটাকে আমরা 2l বলি, ঠিক আছে? 2l is called length of dipole and O is center of dipole. তো আমরা কি ডিসকাস করেছিলাম ডাইপোল মোমেন্ট, ঠিক আছে? ডাইপোল মোমেন্ট which is defined as what? The distance between the two charges multiplied by value of each charge, magnitude of each charge, and direction is from negative to positive. Suppose along the direction in care. Dipole moment unit ki hai? The SI unit was coulomb meter, ঠিক আছে? And the dimensional formula for dipole moment is what? It is AT multiplied by L, right? এবার যেটা বলছিলাম লাস্ট ডে কি দেখ সব সিস্টেম, রাইট, যে কোনো সিস্টেম কিন্তু এরকম একটা সিস্টেম যেখানে টোটাল চার্জ জিরো, ডাইপোলের টোটাল চার্জ জিরো, তো এনি such system where the total charge is zero, which can be reduced to a pair of negative and positive charges, can be called a dipole, ঠিক আছে? ফর এক্সাম্পল ধর যদি আমার কাছে এরকম একটা সিস্টেম থাকে, say I have such a system of charges যেখানে ধর একটা ট্রায়াঙ্গেল আছে এভাবে, and in this triangle suppose এখানে একটা চার্জ আছে -2q, এখানে একটা চার্জ আছে +q, and এখানে একটা চার্জ আছে +q, right? Say it is equilateral triangle of side length L each. It is an equilateral triangle of side length L each. তো বেসিক্যালি আমরা কি দেখতে পাচ্ছি যে এখানে টোটাল চার্জ কত হচ্ছে দেখ, +2q -2q 0। এটাকে আমরা দেখতে পারি কিভাবে? we can see this as a pair of two dipoles. এই -2q কে আমরা দেখতে পারি a pair of -q with +q. This will give rise to one dipole moment, suppose p1, and another -q + q will give rise to another dipole moment, let's call it p2. আর যে resultant dipole momentটা হবে, it will be the vector sum of both these dipole moments. Okay, so that will be the resultant dipole moment P. Right? If you find the vector sum, যদি এটাকে আমরা parallelogram law দিয়ে vector sum find করি, তাহলে আমরা পেয়ে যাবো ওদের resultant dipole moment which is P. Suppose this is P. So ultimately as it is equilateral triangle, অ্যাঙ্গেলটা কত হবে? 60 ডিগ্রি হবে। তো the angle between P1 P2 is 60 degree. তাহলে আমার resultant dipole moment এর ম্যাগনিটিউড কত হয়ে যাচ্ছে? root over of P1 হচ্ছে Q into L, তাই তো? Value of each charge Q, distance হচ্ছে L, তো Q into L square plus Q into L square plus 2QL square cos 60 half হয়, তাহলে ultimately we will get what? √3QL. and direction কোন দিকে হবে? Direction will be along the angle bisector of the angle between the arms having charges -2q and +q each. বুঝা গেল? তাহলে আলটিমেটলি কি দাঁড়াচ্ছে যে এই সিস্টেমটাও ইজ লাইক আ ডাইপোল and its resultant dipole moment is P. এবার দেখ যদি এখানে আমরা জিনিসটাকে ভালো করে দেখি, তাহলে we can see that if this dipole moment, if it is rewritten, যদি এটাকে আরেকভাবে দেখতে চাই, আমি এভাবে বলতে পারি here the dipole moment is coming কি √3 times of QL, কিন্তু here total negative charge was 2q, total positive charge was 2q. তাহলে এটাকে আমি লিখতে পারি √3/2 into L into 2q. তাহলে আলটিমেটলি কি মনে হবে? that the effective dipole length will be equal to √3L/2, তাই তো? effective dipole length will be equal to √3L/2, as if আমার -2q এখানে আছে and virtually at distance root 3l by 2, which is equal to height of the equilateral triangle, এখানে আমার কাছে আরেকটা চার্জ আছে, imaginary charge, which is suppose plus 2q. Actually ওটা নেই. Actually this charge plus 2q is not present, but it will seem as if a charge plus 2q is located here imaginarily. বুঝে গেল? So we can say এই যে পয়েন্টটা হবে, right, this point can be called the center of positive charge or center of positive charges, while minus 2q will appear as the center of negative charges. বুঝে গেল? তাহলে যখনই আমার কাছে মোর দেন 2 চার্জেস বা একটা ওভারঅল চার্জ ডিস্ট্রিবিউশন থাকবে, যদি সেটাকে একটা রেজাল্টেন্ট ডাইপোল মোমেন্টে আমরা ফাইন্ড রিডিউস করতে পারি, তো ইট উইল অলসো লুক লাইক আ ডাইপোল, and we can say effectively it will seem that the center of negative charges and the center of positive charges will be separated by certain distance. বুঝা গেল?
Yes, sir.
Now suppose আমরা যদি এই জিনিসটাকে আরেকভাবে দেখি, সে আরেকটা প্রবলেম আমি নিচ্ছি, সেকেন্ড কোয়েশ্চেন, I have one semicircular arc. ঠিক আছে, I have a semicircular arc. We have a semicircular arc of suppose semicircular মনে হচ্ছে না, ঠিক আছে? So see, I have a semicircular arc like this. And suppose এই যে semicircular arc টা আমরা ফর্ম করলাম, suppose the radius of this semicircular arc is r. O is the center, r is the radius, and imagine that negative charges, a total negative charge is distributed all over this semicircular arc. Suppose the total charge here is minus q, and there is a total charge plus q at the center. The question is same, to find the net dipole moment of the system. Okay. Question taki very simple question, that we have one semicircular arc of radius r. It is having a charge minus q distributed all over it. There is a charge plus q at the center. What is the net dipole moment of the system? So first of all, what we have to think ki ekhane ki really is it looking like a dipole? Answer is yes, because we have some negative charge separated from some positive charge, and the total charge is here. So in this particular problem, how we will solve the question? So what we can assume is, we can assume ki if I take, suppose if I draw the vertical diameter, and if I take a very small an elementary arc of this semicircle, suppose if I take an arc of length dl, right, which makes a small angle d theta at the center, and suppose if this radius is making an angle theta, okay, so we can say ki a dl tar bhitore, within this dl there will be some negative charge. Let's say this dl contains a negative charge minus dq, and this positive q is like a collection of numerous of such dq's, তাই তো? যদি আমি dq plus dq plus dq করি, so we'll get a positive q. Now this minus dq and a positive dq from here will give rise to a dipole moment. Let's call it dp, right? So we can say that the dipole moment due to the pair of elementary charges plus minus dq will be how much? So dp will be equal to what? Plus minus dq is the magnitude. The charge equal to dq. And what is the distance between them? Distance between them is nothing but radius of the circle. So we can say it will be r into dq. Now, how much is dq? So now see, we have said that minus q is lying uniformly all over the circle. Minus q is lying uniformly all over the circular arc. Therefore, we can say that per unit length, the charge is q by pi r. Right? Per unit length, the charge is q by pi r, magnitude wise. And the element which you have taken has a length dl. So what is the charge on it? Q by pi r multiplied by dl. Further, this RR will cancel out. Further, we know that as dl is an arc of a circle, small arc of a circle, and আমরা জানি যে angle equal to কি হয় arc by radius, right? We know angle is equal to arc by radius. So this dl will be equal to r multiplied by d theta. So the dipole moment dp will be equal to qr by pi into d. So now see what will happen as a result of this, as it is a vector quantity, so we can resolve it into two directions. One, along the line of symmetry of the semicircle. যদি ধর আমি বলি যে line of symmetry of the semicircle is along y-axis. If I call that this is my y-axis and the line along the diameter is my x-axis. So I can say that if this angle was theta, the x component will be dp cos theta, which is going along negative x-axis, and the y component will be dp sin theta, which is going along the negative y-axis. Is that clear? So we can say that the total x component, right? Total dipole moment will have two parts, px along minus I cap and py along minus j cap. So what will be the total x component? X component of dp was dp cos theta. তাহলে total x component কি হয়ে যাবে? Integration of dp cos theta. That means dp was this qr by pi. Qr and pi are constants. The integration of cos theta d theta. कहाँ से कहाँ तक? So see, the angle theta can be minimum 0 and maximum it can be pi 180 degree. Then it will cover the whole semicircle. So this will be from 0 to pi. So now solve it. You will get qr by pi. You know integration of cos is sine. So sine theta from 0 to pi. So that will give us qr by pi sine of pi minus sine of 0. Sine pi means sine 180 degree is 0 and sine 0 is also 0. That means a dipole moment এর কোনো x component থাকবে না. The resultant x component will be 0. Is that clear till this point?
Yes, sir.
Okay. On the other hand, if I want to find the y component, resultant y component, total y component of dipole moment কত হবে? So we can say ki py will be what? Integration of dp sin theta. So what was dp? Just have a look back. dp was qr by pi into d theta. এটাকে solve করব। তাহলে কি পাবো? I'll get qr by pi integration of sin theta d theta from 0 to pi. Now, what is the value of integration of sin theta? It is minus cos theta, right? From 0 to pi. So this will be qr by pi multiplied by minus cos pi minus minus plus cos 0. Cos pi, when cos 180 minus 1 hai. The negative of that will be equal to 1. Cos 0 is 1. So we'll get 2 qr by pi. That means ultimately we can say कि जो हमारा dipole moment टा होच्छे, it is 2 qr by pi along minus j cap along the line of symmetry. And you can see कि देखते की मना होगे. What is 2 qr by pi basically? If you see this very carefully, 2 qr by pi माने कौन location? What is the location? So the negative q was all over the semicircle. and we are finding ki 2qr by pi is acting along the y-axis. So it will seem as if positive charge is at the center and the entire negative charge is located somewhere here. Pi is 3.14. So 2r by pi will be less than r. So this distance O theke this distance is r. So it will be somewhere here. Here I can imagine that the entire negative q charge is concentrated here. This will be the center of negative charge. Is that clear? It will be the center of negative charge. বুঝা গেল? তাহলে ultimately what we will assume? We will assume that this is a dipole where the entire negative charge minus q is separated from the entire positive charge plus q by how much distance? Distance 2r by. Clear?
Yes, sir.
Is that clear? Now, in the same manner, যেরকম আমরা এখানে semicircle করলাম, আমরা সার্কেলের জন্য এটা ফাইন্ড করতে পারি. We can also find it for a spherical distribution also. Now, what you will find out, যদি এটাকে আমরা solve করি, for a spherical case, suppose the negative charge is distributed all over in the volume of a sphere, and there is a positive charge lying at the center. তো আমরা কি দেখতে পাবো? যে the overall dipole moment will be 0. And that is why you know ki in a neutral atom, though we have a positively charged nucleus, we have negatively charged electrons around the nucleus, somehow it does not behave as a dipole. কারণ কি? কারণ the center of positive charge and center of negative charge will be put. Is this point clear? Yes or no?
Yes, sir.
Right. So the point that is very clear ki even a system of a neutral system of electrically neutral system of multiple charges can behave as a dipole if it can be reduced to one point having total negative charge separated from another point having total positive charge. Yes. So now let's come to the next part. This was how to calculate a dipole moment, right? Remember the dipole moment is a vector quantity. So wherever we have more than one possible dipoles together, বা যেখানে আমার কাছে এমন একটা কনফিগারেশন আছে যেখানে more than one dipole moment possible, so resultant will be the vector solution. Yes. Now coming to the case of electric field due to a dipole. So now let's come to electric field due to a dipole. Remember ki if I have a dipole, say minus q and plus q, center is O, and suppose from the center at a point r, which is at distance small r, we are trying to find out the field. This r will be called axial point. Can I axial point? Because it is lying on the axis of the dipole. The line joining minus q and plus q is called axis. So what is found is the electric field at the axial point. This is here given as 2p. P is the dipole moment by 4 pi epsilon naught r multiplied by r square minus L square whole square. And for a short dipole mane r is very large as compared to L, or point dipole mane L tends to 0. We will have E axial equal to 2p by 4 pi epsilon naught r cube. তার মানে এই axial point direction of electric field will be along the direction of dipole. On the other hand, if you take a point lying on the perpendicular bisector of the dipole or r dash, এই পয়েন্টটাকে আমরা বলি equatorial point. This point is called equatorial point. So the formula for electric field at an equatorial point is minus vector P by 4 pi epsilon naught r square plus L square to the power 3 by 2. L taki L is half of the length of the dipole. Right? L is half of the length of the dipole. Again, we can see कि for a short dipole or point dipole, where L is negligible as compared to distance R, हमार E equatorial की हुई जब है, will be minus of P by 4 pi epsilon naught R cube. We can say कि at the axial point, direction between dipole moment, angle between dipole moment and electric field intensity E is 0 degree, right? So at this point, E is parallel to P. On the other hand, here, the dipole moment is from left to right, but electric field is from right to left. So at this point, we can say that E is anti-parallel to P. Anti-parallel means angle between electric field and the dipole moment will be 180 degree. Okay. Is that clear?
Yes, sir. So can you explain for that equatorial point?
At the equatorial point, we saw that E equatorial is vector-wise minus of P by 4 pi epsilon naught something. Minus of P means if dipole moment is acting left to right, the electric field is going right to left. That means angle between dipole moment and electric field at this point is 180 degree. Understood? They are anti-parallel. While on the axial point, they were parallel. Angle was 0 degree. Okay.
Okay, sir.
Now, one more thing we can see that what is done? So one more point we can see for a given distance r from the center of the dipole, what is found the magnitude of E axial will be approximately twice of magnitude of E equatorial short dipole, or we can say point. Okay, for a short dipole or for a point dipole, at the same distance from the center of the dipole, axial field जो होगा वो equatorial field का nearly double हो जाएगा, क्योंकि axial field was 2p by 4 pi epsilon naught r cube and equatorial field was only p by 4 pi epsilon naught r. Everything clear? Yes or no? Sir?
Yes, sir.
Now see, the next important point, जो additional point को क्या देखना है कि field at a general point due to a short or point dipole. At a general point, मतलब suppose हमारे पास एक short dipole, ध्यान से देखो. Suppose I have a short dipole here. This is a short dipole, right? I am drawing it in a larger version, but actually it is small dipole. And say I want to find out the electric field at a point, say R, which is lying at such a point कि अगर हमने उस point को center of dipole के साथ join किया, तो जो पोजीशन वेक्टर बनेगा, if I join the point R to the center of the dipole, center of the short dipole, तो जो position vector बनेगा, right, this position vector will make an angle theta with the axis of the dipole. This line is the axis of the dipole, right? This line is the axial line of the dipole. Okay? And suppose the distance is r from the center. तो यहाँ पे कैसे बने? What will be the field at this? Now see, you know that as dipole moment is a vector, I can resolve it into two components. ये जो p है, it can be resolved as p cos theta along the direction of the vector r. Right? I can see it like a dipole moment p cos theta along the radius vector r, and I can see it as a dipole moment p sin theta, dipole of dipole moment p sin theta, like this, which is perpendicular to r. Yes or no? Yes, sure. तो ये जो imaginary dipole है p cos theta, for this r is an axial point. So we can say कि at the point r, the imaginary or electric field due to the imaginary dipole p cos theta कितना हो जाएगा? किस तरफ हो जाएगा? Along the direction of dipole moment. अभी जो बताया था, axial point पे field is along the dipole moment. So let's this be E1. Automatically we can say कि the value of E1 will be कितना? Will be 2p. p की जगह हो जाएगा p cos theta by 4 pi epsilon naught r cube. On the other hand, p sin theta के लिए ये equatorial point बन गया because it lies on the perpendicular bisector. So for that the field will be opposite to the dipole moment, like this. It will be perpendicular to the direction of r. That is suppose E2. ठीक है? तो E2 का वैल्यू कितना हो जाएगा? P, this P sin theta in this case, by 4 pi epsilon naught. तो resultant क्या बनेगा? If you draw a parallelogram out of these two vectors, okay, if you draw a parallelogram out of two vectors, and if you find out the resultant, you know कि resultant will come along the diagonal. Right? So this will be the resultant field E. Right? So obviously E कितना हो जाएगा? Magnitude of E will be root over of E1 square plus E2 square. कि दोनों के बीच में angle 90 degree है. So if you solve it, you can keep out 1 by 4 pi epsilon naught r cube outside. तो अंदर क्या बचेगा? Root over of 4p square cos square theta plus p square sin square theta. ठीक है? Understood?
স্যার এখানে অ্যাক্সিয়াল আর ইকুইটোরিয়ালটাকে আমরা বার করলে
कारण अमी तो पॉइंट आर तो इज अ जनरल पॉइंट, वहां पे तो माने फील्ड निकालने का कोई जनरल मेथड तुम्हें पता नहीं, but we are doing what we are assuming as this dipole as if it is made up of two dipoles put perpendicular to each other. One of dipole moment p cos theta যার জন্য পয়েন্ট আরটা অ্যাক্সিয়াল পয়েন্ট হয়ে যাবে, আর ওয়ান ইজ p sin theta যার জন্য ও ইকুয়েটোরিয়াল হয়ে যাবে। এবার অ্যাক্সিয়াল ইকুয়েটোরিয়াল ফর্ম আমরা জানি অলরেডি, তো এটা দিয়ে ইজিলি আমরা বের করতে পারবো। বুঝতে পারলো?
না স্যার ওটা বলছিল মানে পি সাইন থিটাটাও তো ইয়ে হতে পারতো মানে অ্যাক্সিয়াল পয়েন্ট
না, কারণ we are interested to find the electric field at the point capital R, যার পজিশন ভেক্টর সেন্টার থেকে হচ্ছে স্মল আর ভেক্টর। তাহলে যেইটা আমার অ্যালং দ্য স্মল আর কম্পোনেন্ট যাবে সেটাই তো অ্যালং দ্য মানে যেই ডাইপোল মোমেন্টটা পি কস থিটা ইট ইজ লাইং অ্যালং আর, তাহলে অ্যালং দ্য আর যে পয়েন্টটা সে তো পি কস থিটার জন্য অ্যাকচুয়াল পয়েন্ট হবে না, পি সাইন থিটা তো পারপেন্ডিকুলার হয়ে গেল, ইকুয়েটোরিয়াল চলে আসলো। বুঝতে পারলে ব্যাপারটা? পি সাইন
হ্যাঁ
থিটা
স্যার
যে ডাইপোলটা সেটা তো পারপেন্ডিকুলার টু আর আছে, পারপেন্ডিকুলার টু ডি এক্সাক্ট আর আছে, এই জন্য ওটা ইকুয়েটোরিয়াল হয়ে যাচ্ছে। Clear?
Yes, sir.
Sir,
हाँ, tell.
so the P sin theta is the equatorial.
No. We are resolving dipole moment P into two parts, right? P cos theta is along the radius vector R. P sin theta is perpendicular to it. So if you forget about P sin theta, if you hide P sin theta, it will seem as if कि जो point R है, it lies on the axis of P cos theta. And if you hide P cos theta, it will seem as if R lies on equatorial line of P sin theta. Understood?
Yes, sir.
Now, you know, if you take 1P square here common, you will get cos square theta plus sin square theta equal to 1. So ultimately, the value of E will be equal to E by 4 pi epsilon naught R cube root over of 1 plus 3 cos square theta. This is the final formula. ठीक है? 4 cos square theta था, उसमें से हमने एक को बाहर निकाल के sin square के साथ रख तो 1 बना दिया, remaining 3 सब. And if I say that it makes an angle alpha with the direction of E1, if it makes an angle alpha with the direction of E1, you can see tan alpha will be E2 by E1. Okay, we can see that if resultant E makes angle alpha with the direction of E1, that is with direction of radius vector R, then we can simply see that tan of alpha will be equal to E2 by E1. So E2 कितना था? E2 was P sin theta by 4 pi epsilon naught R cube, and E1 हमारा था 2P cos theta by 4 pi epsilon naught R cube. तो यहाँ से ये पूरा term will get cancelled out, right? P will also get cancelled out. Sin by cos is tan. So we can say that tan alpha will be half of tan theta, or we can say alpha will be tan inverse of half of tan theta. This will be the direction along which this resultant electric field will act. Understood?
Yes, sir.
Is it clear? This much is done? Yes or no?
Yes, sir.
Next, we have to come to the point that in general we know when a charge Q is placed at a point where electric field is E, then it experiences a force F equal to Q into E. Now you know force क्या है? Vector है. Electric field भी vector है, but charge scalar. And whenever we multiply a vector by a scalar, जो नया vector मिलता है, it will be either parallel to the old one or opposite to the old. Yes or no? Whenever two vectors are scalar multiple of themselves, they are कोलिनियर विद ईच अदर। तो यहाँ पे क्या होगा कि फॉर पॉजिटिव चार्ज फोर्स विल बी along the direction of electric field। जिधर इलेक्ट्रिक फील्ड है फोर्स भी इधर ही काम करेगा। And for negative charge will be opposite to direction of electric field। तो जब हम लोग एक डाइपोल को एक्सटर्नल फील्ड में रखेंगे, whenever we place a dipole in an external field, the two charges -q and +q will experience forces। अब ये दोनों फोर्स इक्वल हो भी सकता है, नहीं भी हो सकता है, डिपेंडिंग अपॉन द कैरेक्टर ऑफ द एक्सटर्नल फील्ड। And that is why a dipole kept in an external field may experience a net force, it may experience a net torque, and it may experience both of them। मतलब एक्सटर्नल फील्ड में एक डाइपोल रोटेट भी कर सकता है, ट्रांसलेट भी कर सकता है, डिपेंडिंग अपॉन द केस, एंड इट में अंडरगो रोटेशन प्लस ट्रांसलेशन आल्सो। तो नाउ वी विल सी कि अगर हमने डाइपोल को इलेक्ट्रिक फील्ड में रखा, एक्सटर्नल फील्ड में रखा, तो उसके ऊपर क्या इफेक्ट। ठीक है, तो बिफोर दैट द टाइम is limited, तो I will suggest you please rejoin the meeting, then we will continue from this। ठीक है, rejoin करो, उसके बाद continue करो।